So we are now going to begin our next unit, which is on stoichiometry. These are essentially the essential questions for this unit, main things you want to be able to recognize and know by the end. And you can see the unit vocab there, the main things you want to know before the end of the unit as well. So as we move on here, so the first thing to talk about is what is stoichiometry. Well, stoichiometry is the branch of chemistry dealing with essentially the amounts of substances that are involved in different chemical reactions. When we talk about reaction stoichiometry, we're going to do calculations based on these equations, these Bounce equations. One important thing is that you need to know the mole ratio. The mole ratio essentially is a conversion factor between the molar amounts of two different substances involved in a reaction. So it'll be written out like this: moles of substance A to moles of substance B. To do these problems, the first thing you want to do is to write the Bounce equation, determine the mole ratio, and you'll do dimensional analysis, which are the bridges that we have been working on. So these came back from the other unit. So if we look at this first example problems here, we have how many moles of HNO3 can be produced between or from the reaction of 1.8 moles of NO2 with excess H2O. That excess H2O part isn't going to make a lot of sense right now, but we are going to talk about that soon, what that matters and why it's written there. So if we look at this problem, we have 1.8 moles of NO2 with H2O. So the first thing you want to do for all of these problems are make sure the reaction is balanced. That right there is not balanced. You can tell because you have two hydrogens on this side, only one on this side. So we're going to write out this reaction first. Alright, so if that's the reaction, we need to balance this first. So this is from last unit. Hopefully balancing is alright. So to figure this out, we need two hydrogens, so we'll start trying to put a 2 there. Now if we do that and we look, we have 3 nitrogens total on this side, so I'm going to try to put a 3 here. So now hydrogens and nitrogens, now we have 5, I should say nitrogens, so make this a 5. So now hydrogens and nitrogens look pretty good. Now we're going to look at our oxygens. We're going to run into an issue potentially here because it's going to be odd, but let's see what happens. So we have 10 plus 1 is 11. We've got 6 and 1 is 7 there, so that's not going to work either. So this is the kind of stuff like we said last unit where you're just going to have to kind of work through these and balance these in your head. That would be a good first start, but if we keep looking at this, we're going to have, this should actually be 3. So double checking, 2 times 1 plus 1 is 3. Now if we check, we've got 6 and 1 is 7, 6 and 1 is 7. So now it ends up checking out. As I said before, you'll run into some traps when you start looking through these like I just did, but you'll keep working through those. Okay, so if we look at this problem, we want to always start with what we're given, just like before. So we have 1.8 moles. Now is where it's going to be really important that you write the label with it. So that is moles of NO2. If you don't write the label of what this is, I guarantee you're going to get confused pretty quickly in this chapter. So we have 1.8 moles of NO2. What we want to do is use the mole ratio. Here's where we're going to use that into play. You're going to use these coefficients out in front when we do these conversions. So right here, we want moles of NO2 to cancel on the bottom. And we want to get to moles of HNO3. So the way that we can go from one substance to the other is using these coefficients out in front. So we can put the 3 here for moles of NO2 because there's a 3 out in front here. Then we can put the 2 here because there's a 2 out in front. So essentially what you're going to do is multiply this by 2/3. So your answer is going to be 1.2 moles of HNO3. So that's the first step, being able to do this step here. This is new. This is the mole ratio step. So if we look at this next problem, it's very similar. You're going to use the mole ratio, so we're going to go ahead and skip this one. If we look at this one, though, we're going to have an extra step there. So just like we were doing in the other unit, you're going to need to be able to go from mass to moles and the other way as well. Also throwing in liters, they're using the 22.4 liter conversion. So this first question, we have how many grams of calcium chloride are made from the reaction of 18 grams of hydrochloric acid with excess calcium carbonate. Okay? So bottom line, the first thing we're going to need to do is write out the reaction here. You always want to start with the balanced reaction. So if we look at this problem, we want to have calcium chloride is going to be a product. You know our reactants are HCl plus calcium carbonate. So then we should have calcium chloride, which is CaCl2. And then the other product here, which is going to be H and this part coming together. So we watch our charges, we're going to have H2CO3. Okay. Now, we're going to make sure this is balanced. So we have 1 hydrogen, 2. That's going to be an issue if I put a 2 here. I have 2 chlorines, 1 calcium, 1 carbonate, 1 carbonate. So that looks okay. So now, we need to find how many grams are made, essentially, if we start with 18 grams of HCl. So 18 grams of hydrochloric acid. The first step is going to be to go from grams to moles, just like we have been doing in the past unit. We need to figure out what number goes here. To know what number goes there, you're going to use the molar mass of HCl, which is going to be 36.45 grams of HCl in 1 mole. Then we're going to do this conversion here. We want to get from moles of HCl to moles of CaCl2. Okay, now we need to put the numbers out in front. There's a 2 in front of HCl over here in the balance reaction, so we'll put a 2 there. CaCl2 doesn't have a number in front, so it's essentially 1, so you might want to write the 1, you don't have to. Okay, so 1 mole of CaCl2. Now we need to get to grams. We're not just looking for moles here. So you need the molar mass of CaCl2. We put 1 mole in the bottom. That's 110. Okay. So now as you look back through your work, everything should cancel like in the other unit. So grams of HCl is going to cancel here. Moles of HCl will cancel. Moles of CaCl2. We're going to be left with grams of CaCl2. So when you do this calculation, you should get around 27.4 grams of CaCl2. Okay? And then, if you look at the second example here, this one's just like that one we just worked through. You'll have to write the Rankine reaction and do some conversions between moles and grams. Now, this last step here, this one essentially is the same type of calculation, only we're going to go from different units. So we're bringing back these calculations from before these bridges. So for example, in this first one, instead of going from liters or going to grams at the end, you would make this liters here. So remember the 22.4 liters in a mole. And then these same things here, we're just going to go to molecules, or we're going to go to particles, which would be the 6.02 times 10 to the 23rd. So as the assignment to practice night, you're going to want to do numbers 1 and 2 in the practice packet under lesson 1. Then tomorrow we'll be practicing these problems more and going through some answers to check to see how your work is going. Go ahead and give this a try. Let me know if you have any questions.